So now, here we have an NPN bipolar junction transistor that's wired as a switch, but the signal that we give cannot stay constant. So we just get a brief flash, unless I got switch bounce. Then we got a bunch of flashes. The switch made and broke connections a bunch of times right there. And so that happens sometimes. If that's a problem, you got to debounce the switch as well. But in any case, we have the NPN bipolar junction transistor right there. The reason why we can turn it on, but it won't stay on, is because of the capacitors. Capacitors let alternating current pass through them, but not direct current. So we press the button, and we get the transistor on until the capacitor charges. Then the capacitor is going to turn off because the current stops. Now we need this resistor right there so that when we release the switch, the capacitor has a discharge path, so it can discharge to get ready for the next pulse. So now, we're going to take a closer look at this circuit where we get a pulse every time we press the button with the NPN bipolar junction transistor switch, even if we have switch bounce, which can be a problem. So there's the circuit, but for our signal, we have a push button switcher, mechanical switch. It makes a connection, and the vast majority of the current is going to go to that capacitor and then turn the transistor on briefly because the capacitor is going to charge and then current will stop flowing. Now, a little bit of current will go through this 100,000 ohm resistor. Exact value doesn't really matter, but you kind of want a 10K resistor there. Probably not a lot more than that. So you got enough current to turn the transistor on fully. Now, when you release the switch, then the capacitor needs to discharge. So that's really what both of these resistors are for. They give a path. They do connect to ground, but they give a path to come back and discharge the capacitor. So now, in the last short, we looked at how you press that switch, 10K resistor, 0.47 microfarad capacitor. We'll let current briefly go through base to emitter, turning the transistor on, again, briefly, because capacitors don't let direct current flow through. But then when we release the switch, the capacitor can discharge through those 200,000 ohm resistors. We'll look at the actual board and see how I built that. So we got positive coming to the top of the switch. And then the bottom of the switch right there, we got the 10K resistor. So when I press the button, current goes briefly through the 10K resistor and a 0.47 microfarad capacitor. Now, the capacitor, as I release the button, it needs to discharge. So we got a 100K resistor coming from that side of the capacitor to ground, which heads back to this 100K resistor to the other side of the capacitor so that it can discharge and be ready to be charged again for the next pulse.